اتكلمنا في آخر فيديوهات عن رحلة الصوت في أذن الإنسان لحد ما تصل للمخ. كذلك الوظيفة التانية للأذن الداخلية وهي التوازن أو البالانس. النهاردة على السريع هنلخص القصتين مع الفيديو موضح لهم عشان بيبقى بكده ختمنا أو قفلنا على موضوع رحلة الصوت عموما. رحلة الصوت زي ما قلنا بتبدأ من الأذن الخارجية، بتجمع موجات الصوت، صوان الأذن يجمع موجات الصوت يمشي في الأذن الخارجية لحد ما يصل للإير درام أو طبلة الأذن. هنا بيحصل لها اهتزازات. هذه الاهتزازات بيتم نقلها عن طريق الثلاث عظيمات الموجودين في الأذن الوسطى، المطرقة وبعدين السندان ثم الركاب. ضوء الركاب الأخير دوت بيبقى واصل للأذن الداخلية. الأذن الداخلية اللي فيها القوقعة عضو السمع الأساسي بداخلها الأورجان أوف كورتي، والاهتزازات اللي حصلت دي بتنتقل هنا بتخش على سائل أو فلويدز اللي هو الليمف والاندوليمف الموجودين في القوقعة والأورجان أوف كورتي. اهتزازات الشعيرات او رؤوس الشعيرات، رؤوس الخلايا الشعريه الموجوده في الاورجن اوف كورتي دي بتؤدي الى تحويل الصوت الى او موجات الصوت تحويلها الى موجات كهربائيه او موجات عصبيه. بيتم نقلها عن طريق العصب السمعي الكوكليار نيرف او العصب القوقعي اللي هو جزء من الفيستيبولو كوكليار نيرف. بيتم نقلها الى البرين في كذا محطه في المخ لحد ما بتصل الى البرايمري اوديتوري كورتكس او منطقه السمع الاوليه في القشره المخيه في الفص الصدغي من المخ. وهناك بيتم تفسيرها او بيتم تمييزها على ان هي صوت انسان، صوت حيوان، دوشه، موسيقى، اي حاجه من هذا القبيل. ونشوف الفيديو دوت الموضح اكتر للكلام اللي قلناه. يعني سبحان الله، اعجاز في اللي يعني لما تتخيل الرحله دي اعجاز فعلا لحد ما الصوت يوصل للبرين. في فيديو تاني برضو نشوفه على السريع كده، هو ممكن يوضح اكتر رحله الصوت لحد وصولها للأوديتري كورتكس في برايمري أوديتري كورتكس في البرين.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates three tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
أما بالنسبة للتوازن زي ما قلنا اللي هو برضو وظيفة للأذن الداخلية. يعني أحد مصادر التوازن اللي هو اللابرنس أو الجهاز الداخلي الفيستيبولار سيستم اللي موجود في الأذن الداخلية. ده هنشوف عنه الفيلم التالي، وإن شاء الله يكون واضح ويوضح لنا أكتر صورة عن موضوع التوازن.
The vestibular system is the sensory system our brains use to process movement using the perceived pull of gravity, structures in our inner ears, and through processing visual cues from our eyes. This information is necessary for balance, motion, and spatial orientation. The vestibular system is made up of several parts primarily located in the inner ears in a series of interconnected chambers called the labyrinth. The labyrinth has 3 semicircular canals, each oriented in a different plane to detect different movements.
In the micro-G environment here on the space station, the pull of gravity our body is accustomed to is different, and the vestibular system receives mixed messages. The semicircular canals sense head rotation in space, just as they do on Earth. Because the otolith organs rely on gravity to detect linear motion, they don't function the same way in micro-G as they do on Earth.
You've probably experienced similar mixed messages on Earth. Some people feel dizzy when they read a book in a moving car. The structures in your ear pick up on the motion of the car, but your eyes are fixed on the motionless book. These mixed messages can cause dizziness as your brain tries to determine if you're at rest or in motion. We call that dizzy feeling motion sickness.
Docking sequence is complete. Welcome to the International Space Station.
Turns copies and docking complete. I'm happy to be here at the ISS.
This is similar to the way many first-time astronauts feel when they arrive on the space station. Up here, we call that space adaptation syndrome, or space motion sickness. This is a period where our bodies are adjusting and orienting to the new free-fall environment. One way we fight off space motion sickness is by reducing our body movements until we are acclimated. We also use labels, signs, and the design of the station to help orient ourselves. Lights are positioned up along what we call the overhead, and air intakes are positioned down towards what we call the deck. When we return to Earth, our bodies once again must adapt to perceived change in gravity.
Close your eyes and think about where you are right now. Can you determine which way is up with your eyes closed? What about down? Now, open your eyes and think about what signals you receive to help you determine direction. On Earth, we perceive up or down relative to gravity. While in orbit on station, we're essentially in free fall. There isn't a true up. Up could be anywhere.